Hello and welcome to TK Services. I am Tarun Kehair, and this is my YouTube channel, Concept Canvas. Again, a channel which is meant purely for people who want to specialize in finance and maybe pursuing future courses like CFA, CA, CS, FRM, etc. So today I'm going to be talking about VAR, which is value at risk. This comes under the subject of financial risk management, a very important relevant topic for students who have actually enrolled for the FRM examination. And VAR is a very critical topic because it has very widespread applicability, and the concept is extremely uh, critical in making crucial decisions and making crucial estimates which can help in risk management. In terms of the coverage, I'm going to be talking about various aspects. First of all, let's discuss what VAR is about. What is VAR? What is the importance of Z scores, standard normal distribution, the calculations revolving around value at risk, the application, and inferences that you can draw from VAR. So let's first understand how we interpret VAR. Okay. Now, if you look at those three boxes here, VAR 5% of $25,000. What does that exactly mean? Now, it basically means you can state with 95% confidence level that the losses will not exceed $25,000, or rather you can actually have gains, okay, which is this box here. 95% chance that the loss is less than $25,000, or you could possibly end up with a gain. Whereas it also indicates that VAR, basically there is a 5% chance of probability that the losses will actually exceed that threshold of $25,000. In other words, it basically tells you that the value at risk is $25,000, a 5% chance that the losses will exceed $25,000, or you can state with 95% confidence level that the losses will be less than $25,000, or you could possibly end up with a gain. Now let's move to what is the standard normal distribution. Again, very important in explaining as well as understanding value at risk. What is a standard normal distribution? So if I want to exhibit this in the form of a graph, a standard normal distribution probably looks like a bell curve. It looks like something like this. Okay? So there are two tails here. This tail that you see here is the left hand side tail, and the tail that you see here is the right hand side tail. If you see, the maximum values will lie under this region, okay, and a few values will lie on the left tail and a few values will lie on the right tail. This curve is also called a bell-shaped curve or a bell curve. Now let's also understand what these symbols would mean under a bell curve or a standard normal distribution. Now, what does this X bar mean? X bar basically means the mean of this distribution. You can see here, the mean of a standard normal distribution is always 0 and the standard deviation is 1. Okay. Now, which means that if you go to the drawing, this particular distribution or normal distribution will have a mean of 0, standard deviation of 1. If you were to take the standard deviations away from the mean, so this is one standard deviation away on the left hand side, two standard deviations away on the left hand side, three standard deviations away on the left hand side, one standard deviation away on the right hand side, two standard deviations away on the right hand side, three standard deviations away on the right hand side from the mean. Now, what do these values indicate and how significant are these values? Now, if you look at either of these sides, let's look at the values which lie within one standard deviation of the mean. You will observe typically it has been calculated that about 34% of the values on either side will lie within one standard deviation of the mean. As I told you, maximum values will lie. So that's about 68% of the population will lie in this region. Then if you come to the two standard deviations away from the mean, you will see that about, let's say, 13% of the values will lie within two standard deviations away from the mean. So that makes it a total of 68 and 26, 94%, and the balance 3% on either side will lie in the region of three standard deviations away from the mean. So that completes the 99.99% population. If you look here, you will see that about 68%, as I told you, lies in the region of plus minus one standard deviations of the mean. 94% cumulative will lie within two standard deviations of the mean, and about 99.99% of the population will lie within three standard deviations of the mean, and that is the maximum range. So that is how mean standard normal distribution works. Remember, the mean of a standard normal distribution is 0, and the standard deviation of a standard normal distribution is always 1. Now let's look at some specific applications of the standard normal distribution. One application of the standard normal distribution is finding out the z-score. Again, what do you mean by a z-score? So let me first illustrate that to you. If you want to interpret z-score in terms of a formula, z-score is basically z is equal to x minus mean divided by sigma. What does this mean? This means, let's say, x minus m. What is x minus m? X minus m is basically the deviation of the mean. So x is your value, m is the mean of the distribution. So the value, how far is it from the mean? So that is the deviation divided upon standard deviation, which will basically tell you how many standard deviations away from the mean. So that's what z tries to do. Z tries to plot how many standard deviations away from the mean is that particular value that you are ascertaining. Okay. Now, how do you look up the Z score on a table? Is there a technique for looking up a Z score on a table? The answer is yes. Now, for example, what will be the Z value for a 1% var? 1% var, now if you look at 1%, 1% is the probability. So there is a 1% chance, as I told you when we were looking at the definition of value at risk. 1% basically means there's a 1% chance that the losses will exceed the threshold. Okay, so 1% is nothing but 0.01. Remember, when we are talking about Z scores, when we are talking about value at risk, we are interested in the left hand side of the tail. So that's where all the losses will lie, and then you have the zero, and then you have profits towards the right hand side. So if you look at the standard normal distribution, we have to find out the probability of 1%, which is 0.01, which is, if you see, I have highlighted, it is between these two values. So if I were to look at the Z score, this will be 2.32 or 2.33, between 2.32 and 2.33. Maybe we can look at it and say that the Z score is minus 2.33. Minus 2.3, and you have 0.03 here. So minus 2.33 is the Z score for a 1% var. Similarly, what is the Z value for the 5% var? If you look at the 5% var in the Z table, 5%, the probability is 0.05. So 0.05 comes between these two values, which is minus 1.65. So that's how a Z table will give you the values for different probabilities. Let's quickly jump to a first question, a very simple illustration which will tell you how value at risk is arrived at and calculated. Very important. I'll first read out the problem for you so that you're absolutely clear about what is desired. You are a portfolio manager and the portfolio size is $5 million. The average portfolio return is 12.5% and the standard deviation is 7.5%. What is the 10% VAR, value at risk? also estimate the monthly VAR and the daily VAR. Now, having read the question, I have also got the solution for you. So let's quickly go to the solution and try and show you the calculations. Now, if you look here, the portfolio you saw was $5 million. So this is here, okay. The expected return from the portfolio is 12.5% and the standard deviation is 7.5%. Remember, we are being asked in the question to find out the 10% VAR, which basically means that what is the chance or what is the value at risk with a 10% probability, which means if you take, let's say, whatever is the VAR value or the threshold, you can say that there is a 10% risk that the losses will exceed that threshold, or you could also say with a 90% confidence that the losses will be less than that threshold, or you could possibly even have a gain. What is that threshold is the question, and that, my dear friends, is the value at risk. Now let's first see what 10% will give you in terms of, if you look at the Z tables in the manner that I taught you, you will observe that the Z value for 10% VAR, or basically zero point 0.1, if you trace 0.1 in the chart, it will correspond to a Z value of minus 1.28. I am purposely not showing this to you because I have already shown you two VARs with 5% and 1%. So this is a test for you or a homework for all the students who are watching my video. A 10% VAR, try to fetch it from the Z tables, you should get minus 1.28. Which basically means that for the value that we are looking at, let's take the value as x. So I told you z is equal to x minus mean by sigma. So x minus mean is 12.5 by sigma, which is 7.5, should be equal to minus 1.28. What is that? That means 1.28 deviations away from the mean on the left hand side. Now if you solve for x, you will get x to be 2.9%. Now, what is this 2.9%, dear friends? This 2.9% is basically the return that you are expecting. So, 50 on a $5 million portfolio, a 2.9% will give you, let me open up this formula for you. $5 million into 2.9%, $5 million into 2.9% will give you a return of $145,000. Whereas your expected return from the portfolio is $5 million into 12.5%, which is $625,000, which means you have a probable loss of $480,000. This is your value at risk. Now the question is, how do you interpret this? Again, as I mentioned to you, there is a 10% chance. Remember, we have found out the VAR, 10% VAR. So there is a 10% chance that the losses will exceed this threshold of $480,000. Whereas you could also state with 90% confidence that the losses will be less than $480,000, or you could possibly also have a gain. The next question is, does Excel give you that flexibility of finding out VAR? Let's try and look at it. If you look at VAR, if you look how I have done the VAR, let me first open up the calculation for you. VAR is D3 into norm.s.nv into D7. Now what is D3? This is your portfolio value. Now norm.s.nv is basically giving you your Z score at a probability of 90%, and D7 is your volatility, which you see here. That's how you calculate VAR. Okay, so let's see if that's correct. It comes to, so for example, let me do it for you live so that you're able to understand. So your portfolio, first of all, we need to find out what is norm.s.nv. Let me first do that for you. Norm.s.nv at a 90% probability, which is in this question, will give you 1.28. Note, my dear friends, 1.28. This is your Z score, which we have already found out. I found this out by the manual method or the formula method, and you see that Excel also gives you the same Z score using the formula norm.s.inv. Now, what is the VAR? VAR is basically your portfolio value multiplied by your Z score multiplied by your volatility, which is 7.5%. So this is your VAR, which is 480 odd $1,000, which we have already calculated. Mind you, this is the annual VAR. So now you must be able to, if you look at the question, it has also asked you to compute the monthly VAR and the daily VAR. How will you compute the monthly VAR? Remember, for VAR calculations, you will take 252 working days in a year. And for the monthly VAR, you should ideally take 20 working days in a month. So if you take 485.82 and multiply it by square root of 20 by 252, you should get your monthly VAR. Similarly, for your daily VAR, if you take your annual VAR and multiply it by square root of 1 day divided by 252 days in a year, you should get your daily VAR. So if you look, these are the values that I have calculated and these will match the values that are given here. So that's how value at risk is calculated. So there are a few learnings that you had. You have now understood what is value at risk. You also know that there could be two interpretations of this value at risk, which we discussed. For example, in this problem, a 10% chance that the losses will exceed $480,000 or a 90% chance that the losses will be less than a $480,000 or you could possibly end up with a gain. You also learned how to compute the Z-score by the formula method as well as the Excel method using the function norm.s.inv. And you also learned how to find out the value at risk by using simple business logic as well as using Excel. And lastly, you also learned how to convert the annual VAR into the monthly VAR and the daily VAR. Okay, now let's move to a little more complex an illustration. The next question says the mean expected return for a portfolio is 9% and the standard deviation of the portfolio is 15% annually. Assuming a standard normal distribution, estimate the probability that the return is less than 6%. Estimate X% if it can be stated with 90% confidence that the return is more than X%. And lastly, estimate the 1-year VAR 10% for an INR 100 crore portfolio. Okay, I hope you have read this question. If you haven't, you can copy it down and we will move forward to solving this particular question. So now I go to the complex illustration problem. Here you go. So I have plotted down what is given in the question. The mean security return is 9% annually and the standard deviation is 15% annually. The first question is, what is the probability that the return is less than 6%? Now, before you even attempt it, let's quickly try and plot this down in a graph so that you understand. So if there is a graph like this, and this is your standard normal distribution, your mean return is 9%. Okay, standard deviation is 15%, which you just saw. Now remember, we are bothered about the left hand side because that's where your losses will lie. You want to know that at 6% return, what is the probability that the return will be less than 6%, ladies and gentlemen. So less than 6% basically means this side of the graph or this shaded area. This is the shaded area which will give you your population or the probability, cumulative probability that the return is less than 6%. And this is what we seek to find out. So what is the first step? The first step is to find out the Z score for 6%. What is the Z score for 6%? Applying the formula, Z is equal to X minus mean by sigma. So your Z will be X, which is 6%, minus mean 9% divided by sigma 15%, which is nothing but minus 3 by 15 or minus 0.20. So that means the Z score is minus 0.2, and that's why it is on the left hand side. So this is how we get the manual Z score. So guys, let's look at what this Z score will give you in terms of probability, which means if you look at the graph, what we're trying to find out is a cumulative probability for this particular range, which is mapped by this Z score. So let's see if the table can give you that. Here's your table. Here is Z minus 0.2. So if you look at this number here, it's 0.42074, which basically means there is a 42% probability of 42.07, which is what I have given here from the tables. Okay, so 42.07% chance that the return would be less than 6%. Now, what is there a particular formula which gives it? Yes, there is a formula, and now my dear friends, you will note down the formula. The formula is simply norm.dist, basically normal distribution. So let me try to find out this formula for you, or write it down. Norm.dist. If you see the parenthesis, x is nothing but the value. So we are taking the value as 6%, mean 9%, standard deviation 15%, cumulative, yes, so I'll write true, bracket close, convert that into percentage, and you get your probability answer. So this, my dear friends, is the answer for the second question. What is the probability that the return is less than 6%? The answer is 42.07%. What is most important for people who are studying FRM or people who want to study about value at risk is the interpretation. The interpretation, dear friends, is that there is a 42.07% chance that the return is less than 6%. Now let's look at the second question. The second question is, it can be stated with 90% confidence that the return is more than X%. What is X? I repeat, it can be stated with 90% confidence that the return is more than X%. What is X? Now again, we will draw a separate graph for this. So, and let us try and draw it. So here is your graph, and here is your normal distribution. Now you have the question is, it can be stated that with X with 90% confidence, this is your 90%, that the return is greater than X%. This is your X%. This is your mean return, which is 9%, and this is the range. So this, dear friends, is your 10% VAR. So remember, a VAR has two implications: probability that, or the risk that the losses will be below this value, or a 90% chance that the losses will be, or rather the other way around, a 10% chance. When I say below basically means less. On the left hand side, a 10% chance that the losses will exceed that particular value at risk. That means the return will be below, so it's on the left hand side. Whereas a 90% chance that the losses will be less, so that means the returns will be higher, so that is the right hand side. Okay, so the right hand side will also have the zero, the right hand side will also have the profit, but we are concerned about the left hand side of the tail, or the left tail. Now the question is, what is the value of X? So the first thing we need to do, as I told you, is to find out the Z score. Now the Z score at 10% VAR is minus 1.28, which is what you have already found out in the previous illustration. Here you go. The Z score is minus 1.28. So this you already know, you can get from the table. How will you find out the return? Let me actually show you that 1.28 so that you are absolutely clear. Z score VAR 10%. 10% basically means 0.1. So if you look at 0.1, dear friends, it's somewhere here. This one. And this is your 1.28. So that means a 10% probability is at a Z score of minus 1.28. Right? This is the place. So if I apply this in terms of a formula, friends, What do I see? I see that minus 1.28, which is your Z score, is equal to X, which is the return you want to find out, minus mean 9 by 50. So if you solve for X, you will see that, so you get what? Minus 19.2, which we just calculated, should be equal to X minus 9. Therefore, what is X? X is basically equal to minus 10.2%. So that is the return. Return is minus 10.2%. Now let's see if this is what is written here. There you go, minus 10.2%. That's why it's on the left hand side. Does Excel also give you the same value? Now I introduced to you another formula. I have already told you norm.s.inv gives you the z-score. Norm.dist will give you, or norm.dist will give you the probability, and norm.inv will give you the return. So let's apply norm.inv. What is the probability? You know that you're looking at a 10% risk. What is the mean? It's given to you, ladies and gentlemen. The mean is 9%. What is the standard deviation? It is 15%. Close the brackets and then convert this into percentage. You should get minus 10.22%. You get this? So here, what does the question say? It can be stated with 90% confidence that the return is more than X%. What is X? X, my dear friends, on this graph is minus 10.22%. Here, minus 10.22%, which is on the left hand side, which means with 90% confidence you can say that the returns will be higher than 10 point or negative, higher than minus 10.22%. Okay, which also there is another pehlu to this particular interpretation. The other interpretation is there is also a 10% chance that the return will be lower than minus 10.2%. Okay, so there are two different ways of interpreting value at risk. The third question: what is the 90% 1-year VAR for a 100 crore portfolio? Now, I have already told you how to do that. Now, let's look at what you were expecting. You were expecting on the 100 crore portfolio, you were expecting a return of 9%, which is 9 crores. Whereas at a 10% VAR, you are getting a return of 100 crores into minus 10.22%, which is minus 10.22. That means your risk is actually this minus this, which is 19.22 crores. So this is your VAR, dear friends. This is how I have estimated the VAR, which is 19.22 crores. So the answer to question number 3, what is the 90% 1-year VAR for a 100 crore portfolio? The 90% 1-year VAR for a 100 crore portfolio is 19.22 crores. Okay. Now, is there an Excel way of doing it? Of course, I told you. So it is the value of the portfolio, which is 100 crores, multiplied by the Z score, which is norm.s.inv at a probability of 0.90, multiplied by the portfolio volatility, which is 15%, and that will give you your VAR size. So value at risk is 19.22%. So the Excel will match what we just calculated manually. Right? Now the last part, what I have done for the benefit is I have actually plotted the returns. Now why did I start from minus 36 and why did I go up to, first thing you need to understand, why did I start from minus 36 and why did I go to plus 54? Now if you look at the distribution, it is your mean is 9, whereas your standard deviation is 15. I told you it is 3 sigma away on this side and 3 sigma away on this side. So X is your mean. So mean minus 3 sigma, mean plus 3 sigma. Mean minus 3 sigma will be 9% minus 45%, which is minus 36%. Mean plus 3 sigma will be 9 plus 45, which is plus 54%. So what I have done is I have plotted the possible returns between minus 36 to plus 54. And I have also calculated the probability. I have told you the probability will be by the normal distribution function, norm.dist, which is what I have done here. Let me open up one of the functions to tell you. So norm.dist, your x is the return, your mean is the what is given here. Your standard deviation is also picked up from there, and cumulative, it is true. If you write down here, you will get the probability by applying the norm.dist function. Okay, which is what we also did here. If you remember, whenever we have to find out probability, we will use the normal distribution function in Excel. So that's how I got the probabilities. What I meant here is the added. For example, the cumulative probability here is 0.0017. So the incremental probability is nothing but this minus this. Okay. So here it is this minus this. I've just calculated the incremental probabilities here. And then I've also plotted the z-scores. If you see, the z-scores start from -3 and go up to +3. I told you -3 sigma to +3 sigma. And I told you in a standard normal distribution, the sigma is 1. So -3 sigma is -3, +3 sigma is +3. So if you see, the z-scores are beautifully plotted between -3 and +3. And I plotted this in terms of a graph. Here we go. And if you plot this in terms of a graph, you get a clear standard normal distribution or a bell curve, which is what we have been talking about all through. Now let's come to the last question. Now if you look at the last question, here you go. Estimate the 99% 10-day VAR for a security with observed volatility of 20% annually for a portfolio of 1000 crores. Now you have a hang of the entire topic, the concept, the terms, the nomenclature. What you need to do is just apply the formula. 1000 crores multiplied by norm.s.inv 0.99 multiplied by the volatility, which is 20%, and you want a 10-day VAR, so square root of 10 divided by 252. You should get 92.6832, which is what we have got here. So that's how, dear friends, we can calculate the value at risk. Now, my dear friends, you know what is value at risk. You know the definition of a standard normal distribution, the relevance of a standard normal distribution with respect to the topic, which is value at risk, the importance of z-scores, what do they indicate, how do you interpret value at risk, how to calculate value at risk, its application, as well as inferences. I hope you enjoyed learning this topic. It's very interesting, at the same time very relevant. Please refer to your friends to watch it also, I'm sure, if you find it useful. And also keep subscribing, and happy learning. Thank you very much.